Hello friends, welcome back to the topic of number systems. Today our topic in number systems is remainder theorem. Remainder theorem is very frequently asked question. It started with CAT and all the other exams also have followed the same pattern. Remainder theorem can be asked in all the difficulty levels, that is from basic level to the advanced level, in all the type of different exams. And so remainder theorem definitely remains one of the most important topics that are there in the number system. We'll do this topic in two different parts. First we'll test the basics, the conceptual part, and then we'll go on to advanced level in the next video. Okay, so here we start with it. First of all, what is remainder? We need to discuss what is remainder. Remainder, you know that when you are dividing one number with the other, after the multiple, say for example over here we have 6 divided by 4. So 4 is a multiple of 4, and after the multiple, whatever the part is remaining from 4 to 6, that is called what is remainder. So 2 is the remainder in the first case. In the next case, 11 divided by 3, we know that 9 is a multiple of 3, so the remaining part over here in this example would be 2. And in the third case, 18 divided by 5, the remainder would be 3. So this is the basic thing that we have learned in our primary school. So the same thing continues, but this will go on at an advanced level. So there are two properties of remainders, which they are called additive property and multiplicative property. Only the name sounds very hi-fi, but the concept is not that bad. Take this example of additive property. What happens over here is, say suppose you have got three numbers and all of them are divided by 5, and you need to find out what is the remainder when this number will be divided by 5. Okay, so take the first example, 6 plus 13 plus 8 divided by 5. So if we take individual remainders of 6, 13 and 8, that is 1 plus 3 plus 3, and the middle sign remains same, the additive sign remains the same, you get 7 divided by 5, that is equal to 2. So not going by the individual breakup method, if you have gone by the same direct method, what is 6 plus 13 plus 8, that is 27. You divide 27 by 5, you get the remainder 2, or you divide these numbers individually, that is 6, 13 and 8, you divide them individually, you take individual remainder, that is when you strike out 6 you will get 1, when you divide 13 you will get 3, when you divide 8 you will get 3, all the sum will be 7, when you add them up and you divide 7 you will get the remainder 2. Remainder will remain 2 in all these cases, whether it is split in 2 parts or whether it is split in more parts. Similarly, in the next case, the multiplicative property, in the multiplicative property also the funda remains same. Only if you notice here from the previous page, I have just changed the additive sign to multiplicative sign. Okay, so if we multiply this number 6 into 13 into 8, we get the sum as 624, and 624 divided by 5 gives us remainder 4. Not directly multiplying it, if we go by this individual method, that is we take individual remainders of 1, 3 and 3, and we multiply them. 1, 3 into 3 is 9. 9 divided by 5 will also give us 4. So the multiplicative property, that is rather than multiplying, you directly take the remainders, you get the answer. That answer that will remain 4, and this will also remain 4. So the multiplicative property of remainders is followed. This will help you in the topic of calendars also. When you have to when you're given that 10th January, say suppose is Saturday, and you've been asked what is 4th October. So over there you need to find out the odd days that are there in each of the month. So over there, rather than adding up all the months, all the days in every month from January to October, you can take the remainder that is dealt with in the clocks and videos, the clocks and calendars video. You can go and check that out. These are some examples for self practice, which I would like you to pause the video and do all these sums individually. The funda remains same. Okay, now you are done with these examples. Now let me tell you that how, in what method. See over here, I'll guess that third and fourth example were a bit difficult for you. Okay, so there are a few techniques using which we can solve these examples in a quicker manner. So we'll go on to the next concept, that is negative remainders. What happens in negative remainders is, That see, this is the same, these two questions are the same examples copy pasted from the third and fourth example over here. Okay, so let me take the fourth example first. What is happening over here in this fourth example is that the first number had the remainder of 4, so 4, and second had remainder 2 and again 4. Okay, so then we did we'll get 4 into 4, 16, 32, and then we'll get the remainder 2. Instead of that, we can also write this 4 as minus 1. Minus 1, that means the 4 is 5 minus 1, so the remainder over here is minus 1, and in case of 49 also the remainder is minus 1. So what we'll get over here is minus 1 into 2 minus 2 into minus 1, that is 2. We directly get the answer. So here the number is small, the number is 5, but in the next case, if in case the number over here, see, 52 we know is a multiple of 13, but what happens if we get this number over here? We'll get 12 and then 4, 12 into 4 into 12 again. So instead of you will get 144 into 4, which would be a very huge number, and then divided by 13. Rather than doing that, if we do minus 1 into 4 and into again minus 1, so we get the remainder directly as 4. Please pardon my handwriting. Okay, so we get the remainder directly as 4. So this method, this concept will speed up your calculations like anything. Now please pause the video, I'll take you to the previous slide and try to solve the first two examples also using the positive and negative remainders, and see whether you can optimize on it. Okay, so you're better using the concepts of positive and negative remainder wherever it is required, as the need is. So for example, over here 35 is very close to a multiple of 17, that is 34, so we'll write it as 1, whereas 26 is a bit far away, so we'll keep it as 9, or instead of 9 we can write it as minus 8 also. We can write it as minus 8, and this would be again 9. So whatever is comfortable. In the end, if we get, say, suppose minus 2 as the remainder, just taking as an example, if we are left with minus 2, so our final answer should be 15. Okay, I hope you are getting this. If after multiplying all these numbers, that is over here we'll get 9 into 1 into 9 again. After doing all these things, if we are left with minus 2 as the answer, minus 2, then our final answer, the remainder, is actual in reality it is 15, that is 17 minus 2, the divisor minus 2. Okay, similarly in your case also you can do the same thing, 1, 2 and 4. Instead of 4 you can write minus 1. Yeah, here you will get it as 1, 2, 4. Instead of 4, I'll cut this 4 out and I'll write it as minus 1. So here the answer would be minus 2, which will be, the final answer is 3. Okay, 3. So here also, if we multiply it by, we do it by the normal method of positive remainders, 1 into 2 into 4, we'll get the answer as 8, that is 4 into 2, and when we divide it by 5, we'll get the answer 3. So the remainder remains same. There are several methods, so that's why it is a very dynamic topic in which you can do the same question with several different methods. More so when it comes to the powers. Over here, when you have got powers, say suppose this is an example where you have 10 raised to 4 divided by 9. So what is 10 raised to 4? 10 raised to 4 is nothing but 10 into 10 into 10 into 10, right? This like the previous example, we can write it like this, 10 into 10 into 10 4 times. And when we divide it by 9, we'll have 1, the first 10 will give us a remainder 1 into 1 into 1 into 1, that is 4 times. So instead of writing it as 1 into 1 into 1, what we'll do is we'll write it as 1 raised to 9, which is nothing but 1. So our remainder final answer is 1. If you want to try this out, you can try this out on calci. You can take 10 raised to 4, that is 10,000, divided by 9, you'll get the answer as 1. Okay, then there's in most of the scientific calcis there is a mod function, MOD, which gives us the remainder. If your scientific calculator is not supporting that function, you can go on Windows XP, Windows 7 or whatever you have. You can check that on the calculator that is there in your operating system for higher numbers. We'll come on the higher numbers in the subsequent slides. Okay, so here also in this next example, please pause the video and try to think on your own how will we go about it. Shall we take a positive remainder, that is 8 raised to 12, or negative remainder? Okay, very evidently, if we take the positive remainder 8 raised to 12, we'll end up getting a very huge number. That is all the numbers 8 into 8 into 8 into 8 12 times. We can practically not, we can never multiply that in the exam practically. So what we have is, we have a technique, minus 1 raised to 9, minus 1 raised to 12, and we know that negative number raised to an even number is a positive number. Why this happens is because we know minus 1 into minus 1, just I'm going up to the basic level. Minus 1 into minus 1 is a positive number. Okay, so when there is minus 1, two negative numbers multiplied, we get a positive number. When there is another third negative number, we'll again get a negative number. So as a standard form, we say that when a negative number is multiplied by an odd number say suppose 3. So when we have minus 1 into minus 1 into minus 1, we'll get a negative number. But when we have an even number of negative numbers, that is even number of minus 1s, we'll end up getting a positive number. Okay, so here again, before the next example, I'll request you to please pause the video and try to think on your own. I don't want the solution directly, but please try to think on your own. Again, this is one very easy example where we have 8 the multiple. See, in the previous, the difference between this and this was, we were directly getting minus 1 as remainder, minus 1 over here. But what is happening over here is this is a multiple of 8 plus 1, that is 8 into 2, which is 16, plus 1. So we'll end up getting 1 raised to 4, which is nothing but 1. Okay, so then again in the powers, when it is 23 raised to 13 divided by 8, we'll get minus 1 raised to 13, right? Minus 1, that is 23, is minus 1, gives us minus 1 remainder, and it is multiplied 13 times. So minus 1 raised to 13, and since it is an odd number, we'll get it as minus 1 raised to odd, will leave us with minus 1. So our final answer, that is the remainder, is 7. 8 minus 1, the final remainder is 7. You can check this on your calculator also. 23 raised to 13 divided by 8, when you do the mod, you are left with the remainder part only. So you can do this. 15 raised to 11, same. I'll leave the rest to you. Okay, the further, which are difficult topics, which are difficult forms of power and solving all the questions, we'll deal with that in the next video, which is advanced video. Okay, so thank you for now.